In this video, we're going to take a look at section 7.4, which is more material on quadratic equations. So we took a look at quadratic equations in 7.1, where we talked about solving them by using square roots. And there are certain situations where that can be applied. In 7.2, we talked about solving quadratic equations using the quadratic formula. In this section, we're going to take a look at a couple more topics. The first one being what you see on the screen here, the discriminant, which is used to determine how many real solutions a quadratic equation will have. So the discriminant is not solving the equation for you. So I will have students on the test that will say x equals this discriminant, and x is not equal to the discriminant, right? The discriminant is equal to the discriminant. You are not solving it for x. You're not finding out what x is equal to, right? So the formula for the discriminant is b squared minus 4ac. It is the piece of the quadratic formula that is inside the square root, and that is what will determine whether the solutions come out as real numbers or imaginary numbers. And so that's why we're analyzing that particular part of the formula. If the discriminant is positive, the equation will have two real solutions. Right, so if you get a positive number inside the square root, you get real answers, right? And there will be two because of the plus or minus. We're not finding what those solutions are. I think that's what students have a lot of trouble with accepting on this problem, is we're not solving the equation for these problems. We're just identifying what the solutions will look like. And when the discriminant is positive, we know there will be two real solutions. I don't know what those solutions are, but I know there'll be real solutions. If the discriminant is negative, let's skip to that one, then you're getting a negative number in the square root, and so your solutions will be imaginary, which means there will be no real solutions, but instead two imaginary or complex number solutions, right, when the discriminant is negative. If the discriminant is 0, which is kind of a rare case, but if that happens, that means the square root part goes away, which means the plus or minus goes away, because you'll have plus or minus 0. And so that means you get the same answer in either case, which means you really just get one answer when the discriminant is 0. So you'll have to memorize, when the discriminant is positive, this is what it means. When it's 0, this is what it means. When it's negative, this is what it means. But if you can keep in mind the discriminant is the part that's inside the square root, that maybe will help you remember, oh yeah, if it's negative, that means I'll get imaginary solutions. If it's positive, I'm getting regular, normal, real solutions. And if it's 0, that means I'm just getting one solution. All right, so let's practice a few of these problems. So determine the nature of the solutions of the equation. Don't solve this equation. Don't actually use the quadratic formula. We just want to know the nature of the solutions, which means we just want to look at the discriminant. If I can remember how to spell it, I hope that's how you spell it. So it's equal to b squared minus 4ac. Now to find a, b, and c, you do have to follow the same rules that you would for the quadratic formula. It has to be equal to 0 first, right? A is equal to 1 in this case, b is negative 4 in this case, and c is positive 6. So we'll plug those numbers into this formula here. So we'll have negative 4 squared minus 4 times a, which is 1, times c, which is 6. We'll simplify this so we get positive 16 minus 24, which is negative 8. Now don't put x equals negative 8 because x is not equal to negative 8. The discriminant is equal to negative 8. And because it's negative, it doesn't even matter what the number is. Because it's negative, that tells me I have no real solutions, because they're going to be imaginary. Because having this being negative means you're going to have a negative in the square root of your quadratic formula, and that means the answers come out as imaginary solutions. So I'm not sure which description they're going to want on Math Excel. I assume this part will be multiple choice. So it's no real solutions, or you might say two imaginary solutions. They're both correct. So it's just a matter of which description they're looking for. All right. So that's how the discriminant works. It's a much easier problem than having to solve the equation. I still don't know what the solution is to this equation. I wasn't asked to find that. I'm not going to bother with it. I'm just looking at the discriminant and figuring out what the solutions are going to look like. And for this equation, there'll be two imaginary solutions. All right, so we'll do the same thing here. It's already equal to 0. So a is equal to 1, and c is equal to negative 20. b is missing, so it's equal to 0. and we just want to find the discriminant here. We don't want to solve the equation, even though this one wouldn't be too hard to solve. You just add 20 to the other side and you take the square root of both sides. But we're not being asked to solve it. We just want to find the discriminant. So b is 0, so we'll have 0 squared minus 4 times a, which is 1, times c, which is negative 20. All right, so we'll simplify this. We'll get 0 plus 1, not 100. It'll be 80. Sorry about that. Let's undo that. I was thinking 5 times 20 for some reason. It's 4 times 1 times 20. It's negative times a negative, which will be positive, and then 4 times 20, which will be 80. And so the discriminant in this case is equal to 80. That's not the solution to the equation. That's just the discriminant, which is positive, which tells me there will be 2 real solutions to this equation. And so that's what we know about the solutions to this equation without actually finding what the solutions are. All right, let's do one more, and then we're going to move on to the next kind of problem here. So here it's already equal to 0, so we can go ahead and identify a is equal to 1, b is equal to negative 10, c is equal to 25. We're not solving the equation, we're only finding the discriminant here, which is b squared minus 4ac. b in this case is equal to negative 10 minus 4 times a, which is 1, times c, which is 25. Negative 10 squared will be positive 100. And then this will be minus 4 times 1 times 25, which will be 100. So we get 100 minus 100, which is 0. The discriminant is 0, which means there will be one real solution. All right. So just one answer to that equation, and it'll be a real one. All right. So that's how you use the discriminant to determine what the solutions are going to be like without actually finding the solutions. And you might say, well, what's the point of that? Why bother with that? When you're graphing equations of this type, finding the solution to these equations would be like finding the x-intercepts. But the x-intercepts only exist on the graph if the answers are real. And so this would be a good way of determining whether you should even bother finding the x-intercepts. Because if you're going to get imaginary solutions, like in this case, this graph will have no x-intercepts. So I won't even waste my time looking for x-intercepts. So by investigating that ahead of time, I can save myself time on finding the x-intercepts, because it wouldn't be worthwhile in this case because they won't exist. The x-intercepts, there's no real solutions, there's no x-intercepts. So by knowing that ahead of time, I don't waste my time using the quadratic formula to try to solve this equation, because I know the answers come out imaginary. I can't use those numbers to graph this equation, right? So that'd be one use case of why the discriminant might save you a little bit of time, why you might want to know what the discriminant is, for finding x-intercepts. It's useful in that situation, which we'll be looking at in the next couple of sections. So after this section, we're going to be talking about graphing. All right, so the next kind of problem is, I think it's an interesting one. It's really working backwards. You're going to be given the answer, and you want to work backwards to figure out what the problem would look like for those to be the answers, right? So they'll give you what the solutions are, and you want to use those solutions to construct the equation. So if a is a solution to a polynomial equation, then x minus a must be a factor of that polynomial. So for each answer they give you, you will construct a factor based on that answer using this rule that we just talked about right here. And then you multiply all those factors together to get the equation that you're supposed to get that would have those solutions. Right. So let's try that here. So I'm going to skip the directions. The solutions that we want to have are negative 9 and positive 6. So let's start with 6 because that one's going to be a little bit easier. If we want 6 to be a solution, then x minus 6 would have to be a factor of our polynomial. So having a factor of x minus 6 is what would give us our answer of 6, right? Because we would take that factor, we would set it equal to 0, we would get x equals 6 as our solution, right? So if we want 6 to be a solution, then we need x minus 6 to be a factor in our polynomial. What about for negative 9? If we want negative 9 to be an answer, what factor would give us an answer of negative 9? X plus 9 would give us that solution, right? So it would need to be a plus here. So when we set that one equal to 0, right, x plus 9, set that equal to 0, you subtract 9 from both sides, you get x is equal to -9. It gives you the answer that we want to get. So it still follows the same pattern. It's x minus whatever thing we want to be the solution. That's what we want to set up as our factor. So for -9, it's going to be x minus -9. You get the double negative there, which is why this becomes x plus 9. Right? And since those are the only two solutions we want, these are the only two factors that we want. So we'll multiply these together by FOILing it out. So we'll get x times x, which is x squared. X times -6, which will be -6x. 9 times x, which will be positive 9x. And then 9 times -6, which will be -54. You combine the like terms in the middle, so we get x squared plus 3x minus 54. And to make it an equation, we set it equal to 0. And so that would be the equation. Sorry, I'm going to redo that. Let's try that again. This would be the equation that would have as its solutions -9 and positive 6. When you go to type this in the Math Excel, notice it already has the equals 0 on the screen. So when I go to type this in the Math Excel, I'm just going to type in this part into the box because it already has the equals 0 part for me. All right, let's look at one more example of this type. This time, we have some more unusual solutions, but you actually just follow the same pattern. So we want an equation with 7i as a solution and -7i as a solution. So if we want 7i to be a solution, then we will want x minus 7i to be a factor. Now, in all the factoring that we've done in this course, we have never seen a factor with an imaginary number like that. And you hardly ever will. You never take a polynomial and factor it where you get an imaginary number in your factor. That just, in those cases, you would just say you can't factor it, right? We avoid factoring things where the answers would be imaginary like that. We have other ways of dealing with those kind of situations. But for this, working backwards from the answer to the equation, we don't have a choice. So if we want our answer to be imaginary, then our factor is going to have to have that imaginary number in it. So if we want 7i to be a solution, x minus 7i would have to be a factor. If we want -7i to be a solution, then x minus -7i would have to be a factor. And again, we get the double negative, so that's going to look like this. We'll have x minus 7i, and we'll have x plus 7i, because the two negatives together give me a positive. So these would be my two factors that I would need in order for these to be my solutions. So I will go ahead and multiply this out. I will FOIL. X times x is going to give me x squared. X times 7i will be positive 7ix. -7i times x will be -7ix. And then -7i times positive 7i will be -49i squared. And even though our factors had those imaginary numbers, they were carefully chosen so that when we multiply these together, all the imaginary stuff just goes away. 7ix minus 7ix, they cancel each other out. I squared, you have to remember from chapter 6, is -1. So you get -49 times -1, which will be positive 49. And so I'll have x squared plus 49 equals 0. And so that would be the equation that we would need in order to have our solutions be 7i and -7i. Notice for the answer, they already typed most of it out for you, right? They already have the x squared here. They already have the equal 0. So all you would have to do is type 49 into the box here to type the answer in the Math Excel. All right, let's take a look at the last type of problem for this section. So these are quadratic-like equations. If the equation being solved has 3 terms, use substitution to try to rewrite the equation as quadratic. And you want to use a different letter than the variable that is given in the problem. And since most often the variable given in the problem will be x, I tend to prefer to use w as my new variable. So we did this back in chapter 4 for a similar situation. We had these quadratic-like expressions that we wanted to factor, and so we used substitution to turn them into quadratic expressions, and then we could factor them. So we're doing the same thing here, basically. Rewriting these non-quadratic equations by substituting in a variable in a, how do you want to say this? Like, we're substituting in a variable in a very intentional way to make the equation look quadratic. And then once we have it as a quadratic equation, we can solve it using quadratic formula or factoring or whatever else might work. And then once we're done solving it for the new variable, which oftentimes will be w, you take the w back out, you put the original variable back in, and then you solve it further for the original variable, which is what you're ultimately looking for in these problems. So convert it to a quadratic equation by using substitution, then solve as a quadratic equation. Once you solve it, replace w with the original variable and solve to get the solutions to the original equation for the original variable. So let's take a look at an example to try and make some sense out of that. So here we have x minus 13 square root of x plus 40 equals 0. So there's three terms there. It's equal to 0. So this has a quadratic structure to it. But it isn't technically a quadratic equation because we don't have x being squared. So we want to replace the x variable with a new variable so that we do get a variable to the second power so that it does become quadratic. And so the key to this, just like it was in chapter 4, is to look at the middle term. Replace the middle term, which is square root of x, with a new variable, which we're going to use w for. Right? So I know that sounded kind of weird for me to say it that way, but we're going to replace the square root of x with a new variable, which we're going to use w. I almost said the same thing again. I don't know. It doesn't sound right to me, so I apologize. I'm having trouble talking today for some reason. So replace square root of x with w. All right, we're going to use w as our new variable to replace the old variable. So that sounded better. All right. Now, what we would like to see here, I'm going to put a question mark because I don't know if I'm going to be able to make this happen, but I would like for this to become a w squared so that it will become a quadratic equation. But I can't just assert that it is. I can't just say x can be replaced with w squared. I can't make that choice. I've already made a choice, and I have to make sure that this would be consistent with the choice that I'm making over here. And so if I let w become the square root of x, then what would w squared be allowed to equal, right, based on this choice? And to find out, what you would do is raise this side to the second power. Right, so we have w. What happens if I square that? If I square the w, I get w squared on the left-hand side. But if I square the left-hand side, I have to square the right-hand side. And that power of 2 cancels out that square root, and I would just get x here. So this tells me that based on my choice of letting w replace square root of x, that w squared then can replace x. Right? And so indeed, this is okay, right? X can be replaced by w squared. So that's what we just found out over here. I think that's the best way to handle it. I'm trying to think if there's an easier way to see that that's okay, but I can't think of an easier way to demonstrate that. So again, this was the choice we made, letting w replace square root of x. If I square both sides of this equation, it tells me that w squared can replace x. So I think hopefully that made it a little more clear. So this is the choice that we made. Based on that choice, I can square both sides and see that w squared can take the place of x, which is exactly what we have here. So x will be replaced by the w squared because we confirmed that was okay right here. Square root of x gets replaced with the w because that was the original choice that we made. And then everything else is going to get copied down. And now we have a quadratic equation which we can solve. We could use the quadratic formula, but like I said, you should check to see if you can factor first. And I think all of these are factorable. I don't think they give you anywhere you have to use the quadratic formula. So here we want to find two numbers that multiply to 40 but add to negative 13. And there are two numbers that do that, 8 and 5. Right? So we can factor this as w minus 8, w minus 5 equals 0. We'll solve each of these for w. Right? By setting them equal to 0 first, we'll get w minus 8 equals 0, w minus 5 equals 0, and we get w is equal to 8 and w is equal to 5. Right? by adding the 8 over, adding the 5 over. If we type in 8 and 5 as our solutions to this equation, MathXL is going to tell us we're wrong, because if we say, oh, W is equal to 8, MathXL is thinking, well, what is W? What do you mean by W, right? W was not part of their problem, so it's not going to know what you mean by the variable W. It wants to know, what is X equal to? Solve this equation for X. Tell me what X is equal to. And so I'm telling MathXL what W is equal to here. What I need to do is figure out what X is equal to. So I'm done with W, so we're going to take the W back out and put square root of X back in, right? So we're using this right here. Replace the W with the square root of X. So in place of this W, we're going to have square root of X equals 8. And in place of this W, we'll have square root of X equals 5. And now we want to solve these equations for X to find out what the solution is in terms of the X variable. So we're going to solve this for X by squaring both sides, right? That cancels out the power of 2. So we're going to get X is equal to 64 from this one. And here we'll do the same thing. We'll square both sides, and we're going to get X is equal to 25. You don't have to do plus or minus in this case. It's only if you take the square root of both sides of the equation that you have to do plus or minus. If you're squaring both sides, you don't have to put a plus or minus on the answer. And so these would be my two solutions. We have X is equal to 64, X is equal to 25, right? So once you solve it for W, take the W back out, put the original variable back in. In place of the W, we're putting in square root of X, because that's what W took the place of originally. So once we're done with W, put the original thing back in. All right, so I hope that made sense. I feel like my explanations are horrible on this video, so I apologize. Let's take a look at another example. All right, same thing. We're going to do the same thing here. We're going to replace the original variable X with a new variable W. I think this one's a little bit easier to see, I feel like. So here we can rewrite this, X to the 2/3 power, as X to the 1/3 power. Try that 3 again. And then we'll put the 2 outside parentheses. Minus 4 times X to the 1/3 power minus 12 equals 0. Right. And by doing this, it's just easier to see the substitution. Now I will replace the X to the 1/3 power with W in both of these cases. Right. So W will cover up this X to the 1/3 power. So this will become W squared minus 4 times W will cover up this X to the 1/3 power. So again, I'm consistent. W is replacing the same thing everywhere in this equation. W is replacing X to the 1/3 power. Right, that's the important thing, is that W is replacing the same thing everywhere. You can't let W replace one thing here and then something else over here. So for this problem, W, everywhere in this problem, W is replacing X to the 1/3 power. Right. Then we get this quadratic equation, which we can solve by factoring again, right? Two numbers that multiply to negative 12, add to negative 6 would be, sorry, I said the answer, gosh. Two numbers that multiply to negative 12 and add to negative 4 would be negative 6 and positive 2. All right. Then we set each factor equal to 0 to solve for W. But remember, we're not looking for W in this problem. We are looking for X, right? So we'll get W equals positive 6, because we're going to add 6 to both sides here. And we'll get W equals negative 2. But then we want to take W back out, put the original variable back in. W replaced X to the 1/3 power. So when we're done with W, it gets replaced with the thing that it replaced originally. I don't know if that makes sense, but you take the W out, you return the thing that it originally replaced back to the equation. And so what it originally replaced was X to the 1/3 power. I really should kind of stick to the analogy that I like to use in chapter 4, which is like it's a mask. It's covering up. W is covering up the X to the 1/3 power. So when we're done with W, we take the mask back off, and underneath it, we will find the X to the 1/3 power, right? The thing the W is covering up is now revealed again, right? It's X to the 1/3 power. Same thing's going to happen here. Underneath this W, we have an X to the 1/3 power. Right, so W was covering that up, but we're taking it back off, revealing the thing that's underneath it, which is X to the 1/3 power. And then we want to solve this for X. To get rid of this power of 1/3, we will raise it to the power of 3. Because remember, a 1/3 power is a cube root. So if you want to think of it that way, a 1/3 power as a radical is the cube root of x. And then to cancel out a cube root, we raise it to the 3rd power. If we do that to the left-hand side, we have to do the same thing to the right-hand side. Right? And so the power of 3 cancels out the 1/3 power, and so we just get x equals 6 to the 3rd power, which you might use a calculator to determine. I just happen to know this one off the top of my head. It's 216. So we'll do the same thing here, right? This is a cube root. What cancels out a cube root is a power of 3. So we'll raise both sides to the 3rd power. That power of 3 cancels out that cube root. We get x equals -8. And those are my two solutions in this case. All right, so I think I have one more example. Hopefully I can get through this one. Why don't you guys give this one a try? So pause the video, use substitution to replace the x variable with a new variable w so that it comes out quadratic. Solve that equation for w, and then take the w back out, put the x back in, and then solve it for x. And you should get, in this case, I think you'll actually get 4 different answers if you do it right. So give it a try, see what you come up with, then resume the video to see if you were on the right track. All right, so what you want to do with this x to the 4th power is rewrite it as x squared to the 2nd power. Oops, I don't know why I'm putting the equal sign there. And then we have minus 20x squared plus 64 equals 0. All right, so the substitution that we want to do here, the replacement that we want to do, is we want to replace the x squared with a w. So again, the middle term really kind of gives away the thing that w should be taking the place of. So again, we're putting a mask on it. We're covering up the x squared with a w. And we will do the same thing here. Cover up this x squared with a w. This power of 2 gets copied down, and everything else gets copied down as well. So we end up with this equation, which is a quadratic equation. Now this one, yeah, okay, it factors. I'm sorry, I asked you guys to do this one, and these numbers are not as friendly, but it does factor. Two numbers that multiply to 64 and add to -20. You might have to think about it for a moment, but it's going to be -16 and -4. All right, so -16 times -4 is positive 64. -16 plus -4 is -20. So that's how that factors. If you can't figure out how to factor it, you can use the quadratic formula to solve this, and you will get your 2 answers you're supposed to get. So let's continue up here. So you're going to set each factor equal to 0. So you set the w minus 16 equal to 0, the w minus 4 equal to 0. You solve for w in each case. You add 16 to both sides here, and you get w equals 16. Add 4 to both sides here, you get w is equal to 4. So if you use the quadratic formula on this, these are the 2 answers that you should come up with. You wouldn't want to leave it with plus or minus. You'd want to separate the plus case and the minus case and simplify. And you'd get 2 answers. You would get 16 and 4 if you did that. But we're not done yet. We want to solve this for x, not for w. So now that we're done with w, we take the w back out. Underneath it is the x squared that it was covering up to begin with, right? So we'll have x squared equals 16. Underneath this w, it's covering up x squared, so we'll have x squared equals 4. Then we solve these for x. To cancel out the power of 2, you take the square root of both sides. And because I'm taking the square root of both sides of an equation, I have to do plus or minus here. So that's where we're getting 4 answers. So we get square root of 16, which is 4, but we'll have plus or minus 4. And here we'll get the square root of 4, which is 2, but because we took the square root of both sides, it's plus or minus 2. And so we actually have 4 answers here. And if you want to write them all out, it would be positive 4, negative 4, positive 2, negative 2. Those would be the 4 solutions to this equation. All right, so that concludes section 7.4 on more details about quadratic equations.